All right, class, in this lesson, we're going to work on solving equations using multiplication or division. Just did a similar lesson on this where we were doing equations with addition or subtraction. We can see how multiplication and division also work together. When we have the division property of equality, we can divide each side of an equation by the same non-zero number, and it's going to produce an equivalent equation. So in this problem, if 3x equals 12, and I know all of you in here know that that is 4. As soon as you look at it, 3 times 4 gives you 12. But we need to make sure we understand that when we're solving equations, we need to show this step where we're going to divide both sides of our equation by 3. That way 3 divided by 3 equals 1, and we have an x left, 1x. So basically, that 3 and this 3 cancel one another. Then on the right-hand side, we do our division. 12 divided by 3, we get 4. So x equals 4. Just as when the addition and subtraction, we can always check our work, insert that 4 for x, and see if both sides of our equation equal one another. And we see that 3 times 4 does equal 12. So check, we know we're guaranteed to be right, as long as we did all of our calculations correct. This example, we have negative 6x equals 48. So we're going to divide both sides of our equation by a negative 6. And when we divide both sides of our equation by negative 6 divided by negative 6 is going to give us a positive x. We want that variable to be positive. And 48 divided by negative 6 is going to give us negative 8, because we know a positive divided by a negative is a negative. And once again, you can do your check to make sure you're correct. Let's move on to this next example, and you try it. And then come back and see if you got it right. I would divide both sides by 12. And you know that when you divide 12w divided by 12, that's going to give you w on the left-hand side. And negative 96 divided by a positive 12 is going to give you a negative 8, because we know 12 goes into 96 8 times. Once again, you can check that by multiplying 12 times negative 8, and you should get that answer of 96 if you multiply it correctly. Let's move on to the multiplication property of equality. So when we multiply each side of an equation by the same non-zero number, it's going to produce an equivalent equation. So we can solve for that variable. So in this equation, we are going to multiply both sides by 3. So I'm going to rewrite this x divided by 3. Now we're going to multiply this side by 3, and we're also going to multiply the right side of our equation by 3. Now what happens on that left side is these x's, or these 3's, are going to cancel each other out because of cross-simplifying with multiplying fractions. Because we can make this just like that, 3 over 1, which will eliminate and cancel those 3's. So then we're just going to be left with x on our left-hand side, and 12 times 3, which is 36 on our right-hand side. So once we get that answer of 36, we can always substitute that 36 in where x is. So if I rewrite that equation, 36 divided by 3 equals 12, the left side of our equation should equal the right side. And we know 3 goes into 3 one time, and 3 goes into 6 twice. So 12 equals 12. Check. We know we got it correct. Let's apply it to this problem. I'm going to take a little shorter step to do this now that I understand this concept. And I can see I need to get that w by itself, because that's what we do with all equations. So I'm going to multiply both sides by 7. I take 9 times 7 is going to give me 63. And on that right-hand side, I can see that these 7s are going to cancel each other, which in turn is going to leave me with just W on that right-hand side. So 63 equals W. Once again, we can insert that 63 in for W, and 63 divided by 7 is 9. Last one, we'll multiply both sides by 12. And when we multiply both sides by 12, we're going to be left with the x on the left-hand side, because those 12s cancel each other, and x is going to equal 132. Now we've worked with adding, subtracting, multiplying, and dividing equations. So we should be able to apply this to every kind of equation that we have.